Alright, so in this Leetcode challenge, we are going to solve the Sudoku Solver problem. Right, so the problem statement here is to write a program to solve a Sudoku puzzle by filling the empty cells. A Sudoku solution must satisfy all of the following rules. So each of the digits 1 to 9 must occur exactly once in each row. Each of the digits 1 to 9 must occur exactly once in each column, and each of the digits 1 to 9 must occur exactly once in each of the 9 3x3 subboxes of the grid. And then the dot character indicates an empty cell. All right, so let's just do a screen grab of our board. Let's copy that and let's paste it into Ziteboard. And let's talk about how we're going to solve this. Okay, so if we iterate through every cell on the board, and we try numbers from 1 all the way to 9 in each of these, and we validate as we go. Right, so if we try number 1 here, right, so we validate that. So say we try number 1. We validate that number 1 is correct. If it's validated, and when I mean validated, it means that it can actually, it's a valid number in the square. It doesn't mean it has to be the number that's going to solve it, but it has to be valid. So when I validate that, number 1 can go here. So there's no number 1s in this row, there's no number 1s in the column, and there's no other number 1s in this square. So it's a valid number. So if it's okay, if we validate it, we just move on to the next cell. Oops, cell. And if we validate it and it's not okay, right? So we need to, increment, right? Increment a number and try again. So we're going to increment this number to 2 and try again. So if we walk through that, so if we do this, say we got 1 here, put 1 in here, we validate it, it's okay, we move on to the next cell. In this cell, we start at 1, we put 1 in here, but 1 is not going to be valid, right? Because we already got a 1 in this column. We also got a 1 in this 3x3 grid, and we got a 1 in this row, so that's not valid. So that wouldn't be valid. So we go back and we try 2. So we put 2 in here, and 2 is valid, right? So there's no other 2s in this row, there's no other in this column, there's no other 2 in this row, and there's no other 2 in this square. So 2 is a valid value. So we move on to the next one. So we keep doing this, and we validate as we go. So we're probably going to get to a stage then where, so if we fill this in, we get 1. Let's just fill in the row until our validation doesn't work anymore. So we want to, we get to here, we try 1, 2, and 3, we try 4, which is valid. Move on to the next cell. We try 1, 2, 3, 4, 5, 6, 7, try 8. Move on. We try all the numbers 1 to 8, and then we get to 9. So 9 is a valid one. And then we try all the numbers from 1 to 9, and there's no valids. There's no there's no more valid numbers, and we've exhausted all our numbers from 1 to 9, right? So we've exhausted all the numbers from 1 to 9. So what do we do next? So that's when we need to go back, right? So it means that we got the number 9 here. It's not valid. If we tried 1 to 9, it's not valid. So what that means is one of these numbers is incorrect. So we need to go back. So we're going to go back to this one, and we're going to increment this one, right? And see if that's valid. And obviously this one, 9, again, this cell numbers is exhausted. So we need to go back another column, and we go back into this cell. And again, we've 8 here, we increment 8, we get to 9, right? So we're going to go to 9 here. It's valid, so we're going to move on to the next cell again. We're going to try 1, 2, 3, 4, 5, 6, 7, 8, 9, and 8 is not valid, right? 9 is not valid, so we're going to have to go back to this previous one and increment it. And again, if we've exhausted all numbers here, So we're going to end up going back to this one, and we're going to go 4. We're going to increment 4, right? So we're going to try 5, but 5 isn't valid. We're going to try 6, so 6 would be a valid one here. Okay, and then we're going to move on to the next cell. So we're going to continue this back and forth, kind of a brute force trial and error till we're going to get to a stage where we get to the very end and the last cell, and just say, for instance, the last cell is 3, and we run the validation. At that stage, then our board is going to be solved. Okay, so I suppose when we're thinking about how we'll do this, recursion is a good way, where one call to the same method can give feedback, right? You get feedback from the next call. So let's have a look about how we can iterate through the board with this back and forth algorithm, and then use that recursion to give feedback from each of these positions along the way to the previous call. Okay, so what we're going to do first is we're going to copy our validate solution from the previous validate Sudoku challenge, and we're going to reuse that. So I'm just going to paste that in here. I'm just going to remove the class braces and class definition. Okay, so now we're going to iterate over our board. So int I is equal to 0, I is less than board dot length, and I plus plus. Oops. And then we're going to iterate over the rows. We're going to iterate over the columns. Int j is equal to 0, j is less than board of I dot length, j plus plus. Okay, so now when we iterate over our cells, when we get to a cell that's empty, we need to do something, right? So when the cell is on the board of I of j is equal to the dot character, then we need to do something. So as we said in our solution here, we're going to iterate over the numbers 1 to 9, and we're going to validate. So just notice that spelling. Okay, so we are going to have another for loop. Int x is equal to 1. We're going to start at position number 1. X is less than or equal to 9. We're going to trial the numbers between 1 to 9. X plus plus. Okay. So now what we're going to do is we're going to set the board of I of j is equal to x, and we just want to convert that x to a char, that value here to a char. So we're just going to add the char 02 to do that. So we've replaced, in this case, we've iterated to this position, we've got a dot, and now we're going to replace that cell with the number 1. We're going to start at the very first position, and then we're going to validate. Okay, so we're going to use our is valid Sudoku, and we're going to pass in the board. Okay, so that's going to tell us if this is valid. If it's valid, we're going to move on to the next cell, right? So let's just leave this for a second. And what we're going to do, okay, so we're going to do an if Sudoku board is valid, and another condition, we're going to return true. Okay, so if this Sudoku board is valid, right, if this position is valid, we're going to move on to the next position. So what we're going to do in this case, and to allow us to kind of go back on ourselves if we get to exhaust one of the numbers from 1 to 9, we're going to use recursion, right? So we're going to update this solve Sudoku function to return a boolean, and we're going to run our solve Sudoku, and we're going to pass in our board, right? So we're going to say if validate Sudoku, we validate the board, right? If that number is valid, Then we're going to call our solve Sudoku function again, which will come back in here and run through all of this again. But at this stage, obviously, the board is going to have 5, 3, and 1 now. So the next position it's going to get is it's going to move on to this position here. And again, it's going to try the numbers from 1 to 9 to validate and enter that. Okay. So if like a while ago, we went through our sample, right? Our sample a while ago, I think we had 4 in here, we had 8 in here, 9 here, and we got to here, right? So we exhausted all of our numbers here. So after we exhausted all our numbers here, because we're using recursion now, we're just going to return false from this function. So just outside exhausting all our numbers, we're just going to return false. Also, after every if one of these values isn't valid, right? So if we fail the first is valid Sudoku on the board, we're just going to reset our board to the dot value. So because we're going to use that same board, we're going to reset that to a dot, and we're going to go back and we're going to try and increment the previous value. And also then, because this is a recursive function now, we need to think about, when is the board going to be solved, right? So we did talk about, when we done this back and forward algorithm, trying all these different values, validating them, and going forward and going back where we ran into an issue where numbers got exhausted and they weren't valid. We're going to get to a position eventually where all the cells, all the rows and all the cells have been filled in, and we're going to get to our last number and it's going to be valid, right? So in this case, we've iterated through the whole board, right? And we've got a successfully filled in board and everything's valid. So, when we've iterated through the whole board, like here, there's no more dots left, right? So it's not going to go in here anymore. And we get outside this last loop here. We're just going to return it true. So at this point, the board is solved, right? Just seen another mistake. Okay, so that is pretty much our solution. So let's just add in, we want to print out the board. So let's say print, otherwise it'll just print an object. So print a char of board. Let's just reuse these for loops. And let's do system out dot print. We're going to pass in our board of ij. And let's just put a comma to separate the values in the cell. And then we're going to just print after each row, we're going to do a print a new line. And then we'll just print a new line after at the end. Okay, let's give this a whirl. And we got an error here, 134. Oops. Sure. Let's try that. Okay. So, let's print the board. So just before we turn true, we'll have our board. Let's try that. Okay, so we're just printing our board. So as you can see here, we got to the very last point, right? We filled in this one, and then we had validated the board previously before that, and we validated the board with this last value filled in. we've iterated over through our recursion. We've got to the very last call in a recursion kind of tree, and every position has been filled in, every board has been validated, and so we get to this return true stage. So that's the solved Sudoku solution using this kind of a backward kind of a brute force algorithm, and using recursion. So as I said, recursion is good when you need feedback from the next step along the way. So in our case, we needed feedback. When we're at this stage, we need feedback from the previous call, right? So if all the numbers are exhausted in this, that's our feedback that something was amiss along the way to this one, and that can be fed back all the way to the calls all the way along. Okay, thanks for watching.